issued by Traffic Technology Center. Certification is quite common in air traffic, and but I can say products are on the market, and we have a good answer to this kind of specification. Coming to marking for shipping, this slide shows the main principle based on IALA recommendation. I've mentioned it. Day marking by yellow painting of the shaft, nighttime marking by 5 nautical miles lanterns, yellow color at all towers on the periphery and the significant periphery structure with different flashing, short range marking by yellow illumination or yellow illuminated signs, and we have a synchronization and harmonization of flashing light characters of all lights. The short range marking is to identify each single structure. Again, all turbines on the periphery have to be equipped with 5 miles lanterns. Inner structures only need short range marking. And there's a definition to determine what structures belong to the periphery when the towers not be located on a straight line between the SPS. The guideline introduced 2 options for the peripheral light emitted exclusively in sectors outside the wind farm to reduce the amount of light emitted, or 360-degree lights emitted in all directions. The first option does not correspond to the IALA recommendation 0139. The relevant sectors can be formed by use of subsectors with an appropriate overlapping. This also will reduce light emissions, reduction of scattered light, and reflections. Here you can see the specification for the 5 nautical miles yellow lantern, 5 miles nominal range. The calculation is based on IALA recommendation E200 part 2. It leads to a horizontal photometric light intensity of 120 to 180 candela and a vertical beam divergency of 10 degrees. The light emission is limited outside of this angle. According to IALA recommendation 0139, different flashing characters for lanterns at the SPS and for the lanterns maintained at intermediate structures were selected. A certificate is also required for this type of lanterns for use on offshore wind farms. Well, you have just heard how important synchronization and harmonization is. Synchronizing and harmonizing of all flashing lights reduces stress for the navigators and enhances awareness, conspicuity. In good visibility conditions, the single structures can be identified as a coherent wind farm. This scheme is based on NTC, was developed. Coming to the short range marking. For night marking, the label has to be indirect illuminated or illuminated signs. Backlighting have to be used. The required luminance is reduced by a factor of 2 for that solution. I'll show you some examples. An example of an indirect illumination with reflector light. The scattered and reflected light can cause glare and might impair the recognition of the structure. However, I must say this was only a first design on a test structure. The real structure will be equipped with very better with LED reflectors, and a better solution is possible, just to show what can happen and why a specification is really needed. This slide shows an inverse marking of the tower shaft of the signs with a self-illuminated sign. The photo on the right side was taken in the light laboratory of Traffic Technology Center. The inverse marking with backlighting is the preferred solution to minimize unwanted scattered light. However, to indicate the outer structure of the tower, additional lighting may be required. However, this can be achieved with low intensity lights. Well, although the guideline is already in place and we have made good experience, there are many questions left. For example, the visual impact of rotor blade tip lights, or the impact of sector lights, or the influence of meteorological visibility. And that has led to the concept of simulation. At the first step, we create scenarios in a ship handling simulator. Warnemünde Simulation Center was tasked to, I can show you, to visualize the BART 1 offshore wind farm. I've mentioned it in the beginning of my speech. And now I'd like to show you a video. Oh, okay. Video starts. Would you like to reduce the light a little bit? So we see this structure of BART 1, this 8 turbines, and we at first coming from north and have a view to the north corner of this park. You see the lights on the SPS, on the intermediate structure. Now we're switching to night view. We'll focus on a normal bridge height, 34 meters. Okay. That is the red obstacle light. It's very difficult with the projector system to indicate the structure. However, but you can have an idea how the synchronization works. And at the very end of the simulation, you see also rotor blade tip lights, and also the white flashlight that were newly designed. Okay, try it again, change the position to the source. Now with a view from an avionic, a helicopter that's approaching. Oh, this is only one wind farm. It's planned that all wind farms use the same flashing system. I would like to thank the Warnemünde Simulation Center, Professor Müller, for providing me this video. However, it can be seen that we have used here a projector system and we do some measurement. What our intention was to have a real simulator which clearly shows the physics, the light physics. And well, it's a first approach, and ship heading simulator is a very good and well-known tool. And measurement shows that the simulator can very good be used for distances of up to more than 2 nautical miles. For closer distances, we would like to have a computerized model using ray tracing methods and computer monitors, which have a much more high luminance. So this brings me to the end of my presentation. So with a short summary, within the next years we will have large wind farms in the German EEZ. Sufficient marking is of course a key element to ensure safety of navigation for both kinds of traffic, shipping and air traffic. Federal Waterways Administration has developed a guideline that introduces a visual marking system based on the IATA recommendation 0139 and aeronautical regulations. The guideline includes specification for navigation lights that ensure both good visibility on the one hand side and minimizing unwanted light emissions. And a simulation is available too to assess marking solution, and I hope we will have such a tool also for assess other lighting problems, and we have a lot of lighting problems while dealing with 8-ton navigation or with modern concepts, lighting of bridges or crossing inland waterways, for example. So this brings me to the end.